Is this working? Okay, I think it is. Yeah, okay. So here's the project. Now, lately I have been trying to get back into my little personal projects, and this is one I've been wanting to do for a long time. And I have an ulterior motive as well, which is that the things I need to do for this project will be useful to me in my day job. There are people out there, including good friends of mine, who would tell me it is silly to devote free time to something that's for one's work. And I understand the logic of that, uh, but also at the same time, I do still have to do my job. And if something makes my job easier, uh, then I don't immediately want to discount it. Anyway, so the project here is a streaming floating point ALU. And here's the idea. Typically, an ALU, an FP ALU, will do something like having a n by n multiplier with many a bunch of renormalization logic, flyer adder, etc. with a bunch of renormalization logic. For timing, this will usually be, oh geez, I got it. How do you turn off, or how do you turn on line wrapping? Oh, hey, perfect, actually. Okay, so I don't need to zoom in. I can just make the font larger. And, oh good, there's a list of shortcuts. I've been looking for the one to delete a line. I'm getting distracted. Well, whatever. So let's see. Oh, they finally added a toggle switch for this. Oh, that is so nice. Oh, yeah, no, pass on that. Minimap. Interesting. Let's see what that does. Oh, here we go, wrapping. That's what I want. That's neat. Okay, renormalization logic for timing. So usually be split into several clock cycles. Usually we want the number of clock cycles to be small to reduce latency. Well, that's nice, but sometimes it's helpful to have different design variations. By the way, this project is going to take like all day. It's not easy, and there may be some obstacles I haven't considered yet that will make it even harder than I expect. Anyhow, okay, so this is the different design variations. In this case, I want to completely give up on latency and instead minimize area and power as a secondary concern. I still care about it. I completely don't care about latency. If it takes 1,000 cycles, I don't care. This is an exercise to see what we can do. The idea is to have a quote-unquote 1-by-1 multiplier, adder. Come on. I'm typing in the dark here. It's a little bit past 7 in the morning. The idea is to have 1-by-1 multiplier adder and shift our inputs in 1 bit at a time. The expected benefits are less area, obviously. Like runtime precision choice, or like choose FP precision at runtime by having an array of these 1-bit ALUs we can insert a in other words, we have the opportunity to apply permutations on each cycle. I feel like there's, yeah. For example, is it called a Banish network? Is that how you pronounce it? Where's the original paper? In case you're wondering why it's not visible, it's because whenever I Google something, I do it in a window that's not being streamed because although it's probably harmless, it seems like a bad idea to let my search suggestions and history appear on a stream. Speaking of which, yeah, okay. Anyway. Where's the original paper by Banish? You know what? This is not something I need right now. We can do that later. Also, there's a special character you need for the S on Danish, which, again, I don't know how to pronounce. I'm just guessing. I don't know how to type it on the keyboard I have right now, so, well, okay, hold on. I do want to know. I'm just curious now. I believe it is this. That key is not in the same place on my computer as it is on the thing I was just looking at. Alright, well, I'm gonna give up in a second. Oh, there it is. Found it. Oh, maybe I didn't find it. Alright, forget it. This is why my projects never finish. I get sidetracked by things that are unrelated to them. But then again, they are my projects, so. Okay. Potential power savings by gating the clock when the rest of the inputs are 0. The downside is higher latency. This means that dependent calculations will be very slow. Maybe we can do some clever forwarding to deal with this, but we'll think about that later. Okay, now the next thing I need, by the way, just my typical way of writing Markdown is I don't use multi-level headers, I just use header level 3. I mean, unless I really do need multiple sections, but in this case I don't. Okay, let's do a drawing. Well, okay. How am I going to do this? So, alright, let's call this design flow. I guess we'll use CocoaTV. Or just, okay, every module will have some kind of quote-unquote designer level test bench. Sometimes this will be simpler to just do up in Verilog, and sometimes it will be helpful to use CocoaTV. This project has a finite scope on it. Well, that's not entirely true. For the initial, I guess, I don't know, what's the word I'm looking for here? I guess stage of the project. We just want to make one streaming FP ALU and see if it works. Later, we may make an array of these. Well, actually, before we do that, may try to instantiate 2 or more to try out different forwarding techniques to reduce latency on dependent ops. After that, we could try to instantiate a large array and prove that we can do large and useful calculations for these larger test benches, it may be worthwhile to use UVM. But I won't be doing that today because UVM is huge, and yeah, we're not going to do that. Now, there is some unanswered design questions. Do we want our internal... Well, okay, so one big one is, do we want to be compliant to the IEEE standard? Do we want to try different loading point? Well, this is the same question up here. What kind of rounding modes do we want to make available? Well, yeah, anyway. So, I'll update this design flow section as I actually, you know, figure it out. I did a project a long time ago for my school, and what I did is I for every single Verilog file, I had it in its own folder with its own test bench and its own make file. And that wasn't bad. It was decent. So I may do that again. Yeah. Okay, let's start designing a non-floating point, just regular multiplier that is just a 1x1. Well, so when I say 1x1, what I really mean is 1x1 with carrying logic and I'll put it like this: O of 1 memory. What I mean by O of 1 here is, okay, everything in hardware has to be O of 1 in area because you're just going to print it once into the silicon and that's it. But what I mean here is that whether we want this multiplier to do, you know, FP32 or FP16, we don't want the size of the multipliers to have to change based on the size of your floating point precision. Okay. So the first thing I want to do is just see, can I make a, you know what? Maybe, okay. Steps. Maybe it would be useful to first do an integer streaming adder just to bring up a good design flow. Yeah, so we have an immediate choice to make, which is which Verilog simulator we're going to use. If we want to use CocoaTB, it would be best to use Icarus, but if we're using Icarus, then we're not using system Verilog, which is fine, I guess. What Verilator, God, Verilator's so complicated, and it doesn't work with CocoaTV that nicely. Well, okay, Verilator's not that complicated. Hmm. And I don't have a license for VCS, obviously. I mean, I do at work, but not here. VCS is also brings with it its own set of complexities, but it's not as bad as Verilator. Let me think about this. Uh, I'll just use Icarus. Yeah, I'll just use Icarus. So let me get it installed. Okay. And we're also going to need Python, which is probably already installed. Oh, geez. Okay, stop. Stop this. Should we be using Conda for this instead? All right. How does the replit Python template do it? Whoa. Oh my god. Oh my god. What the heck? Oh, this depths. I'd never noticed that depths before because I just never touch it. I don't need Cause. Okay, so they use Python 3.10 full. And this pry bar, I happen to know is how they rig this console to have a Python interpreter in it, which I don't care about. And then this standard air red. I don't know what that means. Now this, I have no idea what this is. Let me look up what that is. Standard air red. Oh, that's cool. That is really cool. It hooks the write system call to check if it's going to the standard air file descriptor, and if so, it will print the terminal characters to make it red. That is really neat. Cool. I wonder if we could use this just on its own. Sure. Let's grab lang 2, why not? Well, you know what? No, I don't like including things I'm not sure I need. Okay, so what happens if I do that? Okay. Yeah. Well, it didn't work. Well, whatever. Wait. Yeah, it is like this that you would write to standard error. Well, this doesn't work, so who cares? Although I'm a little confused why which doesn't work here. Like, whatever. Okay, so let's grab this. And also this. And what's in here? Oh, the end. Man, I don't know how to use venv. Fine, let's do that. Okay. Okay. You know what? We should probably be doing this in this shell anyway. So now what happens if I do pip install CocoaTV? Oh yeah, man. Well, let's just try this one. Permission denied. So yeah, I know it's a dirt. Okay, that worked. So how is this VM being used? Oh, a list of, okay. Okay, yeah, we can do that. I don't really want to see it anyway. Where is this? This is just at the top. Okay. You'll notice I'm doing very little actual RTL right now, which is fine. Like 90% of doing work is setting up the environment anyway. I bet you it's this prybar that's just doing the heavy lifting. Okay. When a virtual environment has been virtual and set to the past, it's explicitly activated. Is not required to. Yeah, I'll bet you it's this prybar Python that they're using. But, okay, if I do which Python in here, now how is that going into the VN? No, how do you show functions? I bet you that was it. No, it still wasn't. Oh, I see. They edited the path. Okay. Okay, let's try that. So I'm also going to need to do oh my god, this stupid encoding's garbage. Why does this keep happening? That means that Python is not installed properly. Okay, let's get rid of this. So env, and I guess just yeah, let's try to use symlinks just to try and keep the space lower. Oh, and actually, I also don't want it to change the prompt. I really don't like that. Wait a minute, though. Well, let's just see what happens if we do this. Okay. Ooh, that's cool. Okay, that seems to be working. Hey, check it out. Okay, that's a result. Oh man. I don't know why that keeps happening. Whoa, 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 whoa. And does this work if I do that? All right, well, it seems to work. Okay, great. So we installed Python and CocoaTV. We installed Icarus Verilog. Now let's, just to keep things simple, normally I would do this on my own, but let's just go and grab the CocoaTV, like getting started code so I don't have to write that myself. Quick start. So let me start with this. Well, fine. I don't know what to call this. I'll just call this delete me, where I'm doing like my no. My little bring up tests, and I'll just call this hello.v. We have to use Verilog because we don't have system Verilog. And I didn't, is this a Verilog? Well, I guess we'll find out. So let me also make a file in here, which I'll just call run.sh, which will be iverilog. Oh, wait a minute. Wait, hold on. Wait, no, you have to use a separate, actually, yeah. Shell CocoaTV config. Oh man. Do you think there's any chance this is? Oh, nice. Fascinating. Just kind of curious. This is probably going to mess up the shell window, but... Wow, no way. Does Icarus support system Verilog? I guess it has to if this example is running. I didn't know that. That changes things a lot, actually. Hold on, I need to know what Icarus supports for system Verilog. It would be nice if it supported structs. I doubt it, though. Come on. Man, this fandom site is so obnoxious. Huh. It's IEEE 1800 standard, which I'm not familiar with. Oh, this is the system Verilog standard. But, like, I don't know what's supported. Well, you know what? Let's just do it. Let's just see if it works. Also, I'm going to put on something to listen to. Yeah. Okay. Yeah, okay. Oh, cool. Very cool. So first it builds the VVP. And it must load some VPI file that's precompiled from CocoaTB. Yeah, okay. I think I understand. So I've seen what I wanted to see. Is this going to break my shell? Yep. Man. Okay, so actually I don't want this. What I really want is this. Okay. Top level lang. I don't know what this does, so I'm just going to ignore it. And you know what? Let's do this since it's advertised to work. And while we're here, let's just see if it supports structs. Man, the indents are all messed up. Okay. And then I also need this. Okay. Whenever I download a tutorial from something, I do like to change the default name so that I understand what has to happen, although this I don't care. I don't understand what this underscore log is, but whatever. What happens if I do that? Ah, interesting. Also, I just prefer it like this. Or a timescale, what am I talking about? Also, this is backwards. I'm just used to it like this. All right. Well, that seems to work. He even gets support for structs and all that. What is this results.xml? Well, whatever. PyCache, what the heck is this garbage? Oh my god. Alright, well, we're not going to look at that. Symbuild commands.f. What's that about? And this is, yeah, whatever. Alright, well, that's a result. So this seems pretty good. Now let's take another look at this makefile. You need to set some environment variables. And you just need to include this. All right. Let's now try doing, okay, now we're done with the hidden files here, so. Well, almost done. Okay, great. And we'll also need to make a git ignore because I do want to put this on git, so. Now, do I remember how to write a .git ignore? No. So, how do you write a dot get ignore? You can prevent directories anywhere. Okay. Okay, this is what we want. I'm done with that. I have that there. So we want that sim build. We want results.xml. Let's actually try that. Ooh. So I don't want this. Oh, I definitely don't want that. Okay, hold on. Actually, wait a minute. What am I doing? Whatever is hidden is what I want to stay hidden. Or ignored. Alright, that makes things a little easier. Whoops. I think I can just do this like that. Okay, and if you don't put a trailing slash, what happens? Yeah, it also matches directories. That is what I want. So did that. What is this dot config? I don't think there is a dot config. So that's okay. And I want to hide the dot get ignore, but I don't want to ignore it, obviously. Okay, now let's go here. Oh, and obviously in the hidden files, I certainly don't want to see that. You see, I knew that when you initialize it, it always does an initial commit, and I really didn't want all those extra files. Hopefully it worked, so. So what I really want to do is push this to remote URL. Oh, jeez. Oh, wait, could I do this on GitLab? Yo, GitLab is way better than GitHub. Oh my god. I would much, 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 much rather do this on GitLab. I'm just trying to find my GitLab credentials. Okay, great. So now if I make a new project, okay, and for the remote URL, oh, but this is gonna need like an SSH key. And I don't want to type in my password every time. All right, we'll do this some other time. I'll do it off stream, but for now, it's fine to have this go to GitHub. Okay. Does this work? Okay. Okay. I do want this, and this is gonna go away at some point, but we have it. Okay, this is looking good. Oof, man, there's so much setup just to do even simple things, but we got there eventually. Okay, so now let's change this to be a little bit more interesting. Also, let me just reformat it to my wants. Also, I guess we can leave this as a logic. I usually make this a wire though for some reason, just to force a habit, I guess. You know what? Just forget that. It's too much trouble. I'm pretty sure there's a linter in iVerilog that will warn me if, you know. Uh, what are we going to do about the carry? Is it just going to be an extra bit? Or the last bit will just be an overflow? Well, let's just do that for now. Okay, so now let's do a reg carry. Does Icarus Verilog support always FF? I hope so. Okay, this is something that I really wish they would let me do this at work, but they never will. Just add a file. Just flop. It's just a flop designed to be less annoying than typing that friggin' always block every time. No. Actually, I tend to do it like this at work, and it's good enough for me, so... Ooh, okay, well, the automatic indentation doesn't like it, so we are not going to do that. Come on. Oh, does this work? I doubt this will compile in iVerilog. So here, I think we need Verilog includers. Okay, I really need to open up the Verilog standard on another tab because I can never remember the syntax for stuff like that. don't have it on this computer. What the heck? Ugh. Oh, here it is. I found it. Okay. Oh, but there's no bookmarks? Oh man, we're gonna do this the hard way. Ugh. And there's not that much front matter on this thing. Just make sure this is not broken. Okay. I must have just skipped over it. Oh, here we go. This is what I want. Whoops. There's about 10 pages of front matter. Yeah. Range. Yeah. Okay, so those work. Hopefully. Okay. And we're going to use active low resets because that's just what we're doing. Okay. Now let's just go in here and so wire sum equals IA XOR IB XOR carry wire carry next is equal to, this is how I write carry logic. There's probably a slicker way to do it. Notice I'm using the 1-bit operators. Maybe I shouldn't do that, just in case I change my mind later on and want to make these, you know. Okay, so now we want a flop. actually. The whole point of this was to make this slick. So here we want and actually like that. Okay. Well, okay, so now we will do, you know what? I just shot myself in the, well, I mean, not I last. Oh, actually, I just realized I need a pipe stage. I guess I don't. I can make this. I can do this without a pipe stage. So first of all, let me just go ahead and assign O ready equals I ready. Assign and yeah, good. I have a particular style when I write RTL, which I am sticking to. So what's the logic here for valid? We are valid if we are oh, actually, this is kind of a complicated piece of logic. Valid if we consume an input oh, but right. Because we don't have a pipe stage in here. So actually, we have to assign O valid equals I valid because we don't have a pipe stage. This is all combinational. Well, combinational with memory. Ah, yeah. Okay. So here we're gonna have a reg state because we're gonna have a separate send carry or send overflow. Although, why do that, right? Yeah, why do that when we could just do this? And actually, well, let's not bother with the carry in. Well, okay. Also, this goes here. Yeah, okay, this works. And we don't need any helper wires. Now, for the test, here's what we're gonna do. Now this is actually something I saw in here and there. Now where did I see that? You know what? Let's just figure it out. Let's just try it and figure it out. Async def, we're gonna send, I don't know, addition. And what we need here is a queue of inputs. So, lists are passed by reference, right? Uh, okay, first let's start by doing so that'll probably be X. No, it won't. Well, yeah, I will because I haven't assigned anything. So let's just try doing just wireless. IA dot value equals 0, or something like that. Ooh, how does this work actually? Hmm. Looks like you can access individual bits. Well, let's just do that. And this should be 1. Just to get us started and also make sure that there are no pieces of syntax that either I messed up or that system or Icarus Verilog doesn't support. Unknown module flop. Also, this is something that we do at work, which is actually really successful, which I forgot about, is if you apply a common prefix to modules, there's a lot of really useful benefits that you get. One is that if you're searching for files in your repo, you can immediately narrow it down to just modules like that. If you're control F-ing inside of a file, you can find instances by control F-ing for the prefix. There's a lot of reasons why having a standard prefix on just modules is really useful, which also means I need to do this. Unknown module type. Now this is including /common. So I guess I need to include it explicitly. First of all, what happens if I do this? Okay. Now what happens if I do that? No rule to make mmflop.sv. all in one. Oh, I see. This is for headers, isn't it? Okay. All right, let's just do this like that. Syntax and assignment statement L value. Oh, whoops. Hello, instantiation. Oh yeah, duh. Oh, that's annoying to have to think of a name for each one. Now I'm starting to see why they don't want us doing this at work. Enable to bind parameter width and hello. None type. Oh, whoops. Unresolvable bit in binary string X. All right. Let's see what happens if we do this. Do we get any BCDs from that? Sim build hello.fst. Man, Replit is so cool. Well, I spoke too soon. right, let's just try. Oh man, oh man, oh man, oh man, oh man, oh man. Fine. All right, I'm just going to reload this page. What are you talking about? And actually, oh, actually, maybe that is working now. Okay, great. Hey. Okay. We are never assigning this, so it should be X. Oh, Z, right. Yeah, it'll be Z. Now these should have value, whoops. These should have values, and they do. Now why is that X? Ooh, that's, okay, hold on. Its carry is X. Ah, because reset's not connected. All right, all right. Let's go in here. I am not super familiar with Coco TV, so you're just gonna have to put up with me while I figure out how to do it. I don't know, let's just make this 10, make this 20. So now here we will await timer of delay nanoseconds, right? And also let's just call this reset thread. And polarity, or let's just say active low equals true. Reset equals 0 if low else 1. then what we need now is that CocoaTV starts soon or whatever. Actually, maybe we should use fork. Ooh. Okay. So now here, let's do await CocoaTV.start reset thread. Oh wait, how do you? Oh yeah, because Python is like that. Right. Okay. Reset end. That should work, right? Okay, whatever. Okay. It's still said. Why is that said? Do we have any warnings? Oh, do we need to do dot value? Oh, we do need to do dot value. And here we can just do this. Okay, this should work. Great. Great. So oh yeah, my period is 2 cycles, 2, 3, 4. Okay. And okay, that seems good. Okay. I'm just thinking about how I'm gonna do this. So let's do async def handshake send. So we need data valid ready last. So here's how this is going to work. Data is an array, is a list. Send each element one by one. And then last is going to be equal to none. If you do not provide last, or I guess I'll put last is optional, but if provided will go to 1 when sending the last element of data. For convenience, you can also omit valid and or so any of the okay, actually what I want is this. All of the wire bindings are optional. What's the best way to do an optional arg in Python? I've never learned how to use the keyword args. Well, we can do that some other time. Oh, I forgot to make this visible. But anyway, so here what I want is when the asterisk where starts immediately before a sequence such as, what the heck is this? Unpacks the sequence into, okay. Oh, you do this. Oh, I don't want to do that. No. I think what I want is the keyword args. Yeah. Ah, okay. Yeah, okay. Fine. So what we're going to do is we're just going to give these okay, so now if type of payload is not lists, right? How does this work? Okay. Then payload is equal to payload. If data is provided, it will be driven according to payload. You will still need to place dummy items into payload so that the function knows how many sets to send. If valid is provided, it will be driven whenever the DUT can read our output. If you set valid only when ready, valid will be driven to 0 whenever ready is 0. If ready is provided, this function will honor the usual handshaking scheme. If not, it will assume the DUT is always ready. Zero otherwise. Okay, that seems good. Now for flit in payload, is this? I really am not familiar with Python. Whoops. Ah, stupid Python. Okay. Payload. So now what do we do? Oh, we need the clock. Duh. Oh my god. Now there's a way. TV dot triggers import. Well, wait, how do you wait for the rising edge? Oh, here we go. Simulator triggers. Fires on the rising edge on a transition from 0 to 1. Okay. Uh... Uh... The reason I am spending so much time really perfecting this function is that this will be useful to just have around for a lot of other things. I mean, in case that wasn't obvious. So now we want to wait for the rising edge. But this, oh man, there's a sort of annoying problem here where this sequence isn't going to start right away. That's annoying. Okay, how do you check if something is none in Python? Okay, but it is defined. Yeah, okay. Good. This will work. Okay, so if so now here what we're going to do is we are going to do if data dot value equals split. If valid, this is some spaghetti logic, but that's okay. If not, does that work? Okay. If not, valid only when ready, or okay, ready val equals none, or ready dot value equals 1. Do I need this? Let's just call this is ready. Valid dot value equals 1. Else, well, we can do this with a ternary statement. You know what? No, let's just do it like this. And now here we need to do this. We need a timeout. Or do we? Setting timeout to 0 means no timeout. Otherwise, if timeout cycles elapse, otherwise if number of cycles between two ready pulses exceeds timeout, throw an error. I don't know what kind of error we'll throw, but okay, and here we will do we need to put this in a loop. Okay. Now we will await rising edge on clock, right? Cycles. Is there a plus plus in Python? Of course not. Okay. If timeout does not equal 0 and cycles is greater than timeout, then man, how do you throw stuff in Python? Python throw exception. Actually, I wonder if there's a Coco TV way of doing this. Dot log. Okay. Yeah, okay. I guess I don't need this if I put an assertion message. Oh yeah, I also need to put last. Oh God. Is this how you do this? Okay. If last, if I equals -1, this we can do with a ternary statement. Equals 1 if blah, else 0. Okay. And then finally, after this for loop, what we want is clear valid back to 0. You know what? I guess it's okay if we have a glitch. Yeah, that's okay. This might cause a glitch in the waveform, but it's okay. Valid dot value equals 0. Okay. I think that's good. Let's try it out. Let's also do a nice little async def random driver sig clock. How do you get random numbers in Python? Man, everything's difficult. Random. Rand? Earned? God, I gotta look it up. Rand int. What? Oh. So I think in Cocoa TV you can get the number of bits in a signal, right? And bits. Well, now, there's got to be a way to do this. let's just try doing the dumb look of here. CocoaTV assign random value to signal. Man, why is this so complicated? I mean, I guess I could just try to use n bits. So let's just do uh, does it include A or not? Man, why is everything so messy, complicated? Okay, it does include it. So what that means. Okay. You know what, this isn't really helping. Let's just turn it off. Okay. So we have a random driver. Let's just start with that and see if that works. Modifiable object has no attribute n bits. Ugh, God. I believe that's how you do it. We will see. Going on. Line 80. So this breakpoint was ignored. Man, I can never remember how to make PUDB work. Oh, no. Oh, actually, I didn't need to do that. No, none of this. Yeah. Okay. Now. Okay, this is a terrible. Oh. Well, anyway. So, sig is a modifiable object. Oh, sig.value.nbits. Okay, well, that's a result. Okay, go in here. No, go in here. Get rid of that. Sig.value. Stupid Python. God. Okay, also, I do want this output, so... Come on. Hello. Hey, how come this doesn't work anymore? You used to be able to click and hold this to have options about like clearing cache or something. Oh, there we go. Well, let's just see what happens if we... do that. Oh, wait. Why is that suddenly okay now? Oh, and this is suddenly okay. Alright, well, you know. Okay, so we want that. We want that. And I valid. Not connected. Right, because I never actually started that guy. Okay, so I ready should be randomly assigned. And it is. Great. Alright, well then in that case, let's just try. I don't know, 10, 20. I don't know, so just put a bunch of random ones in here. So this is the payload. We need the clock, the data. Oh, 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 oh. That complicates things. Dang. Alright, well, let's just start with this just to see that it actually works. Last. Let's just see that it even works. Line 50. Int value 10 out of range of 1-bit signal. Ay, 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 ay. Oh, no, 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 no. What am I talking about? This is supposed to be a 1-bit adder. A streaming 1-bit adder. So actually, just fucking whatever, man. Okay, let's try that. Different error, Z. Line 55. So apparently this already is not being driven, I guess, so this should be reloaded. Oh, now why is that Z? Line 55. Alright, let's just put a breakpoint. So ready is a modifiable object. Oh, but it has... Oh, but it has an overloaded equals sign? Python ignore eq. Python ignore overloaded equality. Python check if none. Oh, is. You use is instead of equals. Stupid. Man, people who like Python are just wrong. Alright, I said it. Hello. What's going on here? Okay. If valid. Is there an is not? Check if not none. Man, Python is so weird. Okay. Oh, I forgot to turn on the waves. Okay. Ready.value.integer. So now this is an ordering thing. Oh man. Oh, but this is an ordering thing. Oh man, oh man, oh man. That's right. So, man. So I think what's happening here is that it's using a PLI delayed assignment. I have no idea what which one it's using. I don't think I want that. Oh, this is deprecated? Well, they should really take it out of their tutorial then. So here's my dilemma. When at least in my original idea here, these coroutines that I'm using to drive stuff in the test bench, when I call them, I expect them to start now. I don't expect them to start at the next rising edge of the clock. But you see, there's a reason why in a lot of test benches, people will drive values at the falling edge of the clock and then read them at the rising edge. And it's because when it comes to Verilog simulators, it takes me so long to like figure it out, but there's actually a specific ordering to when like VPI put value is done relative to like other events for reading, like VPI get value. In other words, what I think is happening here is that when I do in my random driver, which is driving iReady, well, it hasn't started yet, I guess. Well, so if I go over here into my random driver, you see when I assign it this value, it's probably doing a VPI put value, and there are many different modes to put value, and they're all rather complicated. So let me actually just show you that instead of talking about it in the abstract. Because I can just search for it. Yeah, so there are a bunch of choices for, just gotta find it here. For when the value is actually put. Oh, this is get value. Here we go. Yeah, here we go. It's this stuff. So when you call this VPI put value, you fill this structure, and one of the fields that you put in that structure, oh wait, I guess this is in the flags. The flags are actually used to direct a routine to use one of the following delay modes. Okay, so you set it as one of the flags. And it's using one of these modes, and these are all very complicated to understand. Inertial delay. All scheduled events in the object shall be removed before this event is scheduled. And you're like, well, what does that mean? What is a scheduled event on the object? And you're like, well, okay, I guess in the simulator, every thing in the simulator has events on it, but when it says they'll be removed, does that mean that they'll be just deleted and they'll never happen? I guess that is what it means. So this is removed and then it's scheduled. This is no delay. Actually, this is probably what we want. Oh, yeah. Okay. So these delays are for if you actually want to set it sometime in the future. That schedules an event later in the simulator. It's probably using this no delay. But the thing is, if you check the event queue for the, where is that? I believe they call it the stratified event queue. Yeah, so that's on page 64, which I'm going to guess is 74 in this PDF. Close. So there's a diagram here, or I guess some pseudocode. Or maybe there is a diagram, because there is a specific place where the PLI functions get scheduled. You know what? There's a stupider way to do this. Well, I may still have issues with it, but let's actually just do. Let's actually just do this. What happens if I do 0? What does that do for me? Same thing. Okay, what happens if I wait 1 picosecond? Wait, how come this iReady is now... Oh, I get it. Okay. So what happened was, because the ordering of events is difficult to control, so this HS send was being scheduled before this random driver. When I say it was scheduled, what I mean is the read, like the PLI read to that signal, was scheduled before this PLI write for whatever reason. And because of that, the write didn't even happen. The simulation just died before the write could happen. So here, the write did happen at time 0. But actually, this is still saying Z. So why? That doesn't make sense. .o ready. This happens at time 1 picosecond. Everything has got to be so difficult. Fine. So ready modifiable object, binary value, Finster Z, but why? Why? This doesn't make sense. I've done .o ready. All right, let's try something a little dumber. Let's do this and see what happens. What? How can that possibly be Z? That doesn't make sense. Why is that Z? What about this? How is this 1? Oh, wait a minute. Do I have my ready and valid backwards? Is that what's going on here? Oh, I have last before valid and ready. Ah. Alright. Let's solve this problem the Python way, not the C way. Also, this is hard to read. Let me do it like this. Okay, that's definitely the problem. So now let's actually see if this does work. If, oops, that's not what I meant. If I put it in this order without the weight, will it work? I think it should work. Okay. See what happens if we do that. Okay, let's see what happens if we do this. Okay, that's kind of a result. We still have this issue where this put value, if you do a put value, or no, yeah, if you do a put value and a get value in the same simulation tick, it just doesn't seem to happen in the order that you want. But let's just take a look at this waveform real quick and see what there is to be seen. I don't understand. This already is 0. Well, let's just take a look at what's going on here. So, the valid is always high. Let's pull up the data. Data is always 0, so definitely something is wrong here. I don't need this. I wonder if this has something to do with it. No, it couldn't. It couldn't. It couldn't. That doesn't make sense. I guess we'll just put in a breakpoint, right? really no other choice. Now the already does move around, so hopefully this will work to help debug what the issue is. Okay, so we do have a ready on this cycle. Also, oh, I can't read this because it's too small. What is going on here? Okay. So is ready is true, as it ought to be. If valid is not none, which is the case, if, so we should be setting it to 1. Right? Oh, wait, we are. Oh, I get it. I know what's happening. I know what's happening. I forgot to break if it's ready. Okay, that should do it. I still don't know why I need to do this. This is weird. But let's just run this and see what happens. And also let's get rid of the breakpoint. Oh, let's also get rid of, well, okay, it's fine for now. Okay, and also let me just alternate it on every cycle so I can see what's going on. So, okay, let's think about this here. So, on this cycle, we send the first flit. On this cycle, we send the second flit. On this cycle, we send the third flit. On this cycle, yeah, you see. Yeah, you see what's going on here. So ready was 0 here, but when we read it inside that function, we still read it as being 1, because actually we read it right after the rising edge, and we also set it right after the rising edge. So Yeah. And so what's happening here is that on this cycle is when it thinks that we didn't send it. Because it read it here, and that's when it was 0. Man, this is a really, really ugly problem. How do we get around that? How do we get around that? Okay, option 1 is wait until the falling edge of the clock before driving signals. Like the rule is we will always drive our signals on the falling edge of the clock. I mean, let's just do that. I mean, that's simple, right? So here in the random driver, well, let's just do that. And then the waves should start to make sense. Ooh, but they don't. Man, this sucks. Why? Yeah, it's all because of this putting and reading on the same cycle. I mean, maybe my approach of not waiting for the rising edge, but like, when I start a driver, I expect it to start now. I don't expect it to start on the next cycle. Man, this sucks. Why is this so complicated? So the problem I'm having is that putting a value and reading a value on the same simulation tick is ordering them in a way that I don't expect. So one typical solution I've seen is you can only drive values at the falling edge of the clock. But like the reason I hesitate on using that solution is because the whole point of using coroutines is so that you can write, well, so that you can write stuff like this, like this handshake send, where it's like you can just write it in the way that makes sense to you as a human being. You don't have to code up a complicated state machine that has a separate like drive phase and read phase and all right, here's an idea. What if we try putting a force? I mean, this is not going to be a good solution because, well, I guess it's not bad, but the first problem is that it doesn't work. All right, let's read this and see if it gives us any ideas, or at least keywords that we can search. Blah, 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 discrete, blah, blah, blah. Every change in value of an update, update events, evaluation, simulation, stratified event queue. Events that occur at the current simulation time can be processed in any order. These are the active events. Events that occur at the current simulation time, but that shall be processed after all of the active events. Oh, I get it. The grammar here is like this is the list of regions. Region 2 is events that occur at the current simulation time, but that shall be processed after all the active events are processed. These are the inactive events. events that have been evaluated during some previous simulation time, but that shall be assigned at this simulation time after all the active and inactive events are processed. Is the non-blocking assign update events, monitor events, future events. Yeah. The callback procedure schedule is PLI. Yeah. 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 So I think we need to read all the signals. I mean, there's no other option. You need to read all the signals and then you need to drive them. Because, like, if you want to have an arbitrary set of events where it's read this, write that in that order, like, every time you put a value, you need to allow that to go into the simulator before you read anything. There's no other choice. And if the value you're putting depends on something you read, well, you're just going to be reading the old value. Oh, man, this is so confusing. Yeah, because a put value schedules an event, but a get value can't schedule an event. That just doesn't make sense, because otherwise the function couldn't return right away. It'd have to wait until... Yeah, I see. Okay. All right, I think I know what to do. So, first of all, this particular case I'm working with, where there is a um, a ping pong path through the DUT, okay, where the outputs are combinational in the inputs, and I'm driving the inputs. Then there's no choice. You have to drive all your inputs and wait. Now, is there a way in, I think, what is the name of that function in VPI? It's like, oh yeah, it's all the way in the index. Where the heck is the index? What? There's no index? But what? No, that can't be right. I've used this document a million times. But 2001? Whoa, 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 whoa. What? I think this is, I think it's IEEE 2005, it's 1364. Well, it's bigger, so maybe that's a good sign. So what I need to do in CocoaTB, so my preference would be if I could do a wait of 0 cycles. All right, let's actually just try searching for CocoaTB ping pong paths and see if anything comes up. I kind of doubt it. No. No, no. Okay, let's try a CocoaTB combinational paths. Oh, okay. Interesting. So here, let me show you what I did. I just searched CocoaTB combinational paths, and I found this, which looked vaguely helpful. And as I was just like scrolling through like this, see that. Await read only is used to let signals settle after other triggers, such as await edge. You do not want to read signals before all delta delays are completed. Yeah, this read only. So actually, this is a thing from PLI. Also, thankfully, this is the one that has the links in it. It's in, I think it's VPI register callback. There's a particular callback you can use for yeah. Read write sync. Callback shall occur after the execution of events for a specified time. This time may be before or after non-blocking assignments have been processed. It's one of these. So there's this one, there's MBA, there's read only. I think this is what we want. I think this is finally gonna solve my problem here. So that would be in triggers. Fires when the current simulation time step moves to the read-only phase. The read-only phase is entered when the current time step no longer has any further delta steps. This will be a point where all the signal values are stables are no more RTL scheduled for the time step. Now, the simulator will not allow scheduling of more events in this time step. Fires when the read-write portion of the simulation cycle is reached. Let's just see what happens if we wait for this, even though we have put value statements. The reason why it might work is because we can put a value and it'll just schedule it for the next time step, right? But also, what is this read write? There is an explanation for that. Callback shall occur after execution of events for a specified time. See, I remember in my mind seeing like oh geez, there's a thunderstorm going on. I remember in my mind seeing like a bubble diagram. Maybe that's in the system Verilog spec. Okay, let's just search for read write sync and see if we can get some more details on it. The callback procedures shall be treated as inactive events. Okay, yeah, that should work. So, yeah. Oh, hey, cool. All right, let's do that. And let's just try awaiting that and seeing what happens. I like watching thunderstorms, so. Anyway. All right, let's try doing this. Okay, that's different. Line 59. like this. So already definitely isn't Z, but I think it's going to Z on the next cycle or something. So let's just do this. Okay. Also, is there a way in CocoaDB to get access to the simulation time? Well, whatever. Okay, so the very first time this gets called is when? Do I still have that? Yeah, okay, so this should be 0. Then we do start the random driver, which assigns it possibly a different value, I don't know. But this HS send will await for read write. So before we wait for read write, it should be Z, I think. So ready. Z. Okay, now if we step over the await read write, it's still Z. And I just realized something. We have another ping pong path potentially. Like generally speaking, that this HSN function needs to contend with, which is that ready may actually be combinational on valid. So actually, we need to do this after driving valid. Oh, but all right, well. Actually, no, we do still need that there. We'll also put it here. So here, ready is Z, which is what it should be. Or well, just what it is, I guess. It is what it is, as they say. And then if I step over, it's still Z. Why? So clearly this read-write sync does not do what I think it does. Let's go see what other triggers there are. Let's try next time step. I mean, now we're really getting desperate. So ready is Z, which is expected. Then if we step over this, now it's 0. Okay, let's disable this breakpoint and let it run. Okay. So now let's, just for my sanity here, change this to be something like 100 picoseconds so it's more easily visible, or maybe 250. And also let's get rid of this breakpoint. Actually, just a question, does it ignore that? Because invalid time scale precision constant. Oh wow, geez, that's really interesting. I didn't know that. That it can only be a power of 10. All right, well, you know, that's that, I guess. Well, that is weird that it made a difference, but let's inspect the waves and see what we can see. So here at this edge, now this is odd. Why is I valid only is only getting set to 1 here? It's because we waited for the next time step. Man, this is just messed up. So on this cycle we send 1, on this cycle we send 0, 1, 0, 1, and then on this cycle we send nothing. Okay, so here, oh, I see what's going on. It's because I forgot I still had this this right here. Also, I really should just get rid of this assertion. It's not doing anything. Also, let me get rid of this breakpoint. Okay. Now let's see. So at this point, so already goes to 0. So, okay, on this cycle, on this cycle, what is going on here? So A is no, this doesn't work either. I was hoping that next time step would be, well, I was hoping that next time step would do what read-write sync was supposed to do. I want to try that again, just to see what happens. All right, what happens if we try read only? You know? What time is it? Oh my god. How long have I been here? Wow. It's amazing how much time just vanishes when you're fighting with stupid stuff. Okay, well, that made no difference at all. Oh, well, made no difference because I didn't call it. So here it'll probably throw an error that we tried to put something in the read-only phase, but you know, yeah, writes to object iValid was scheduled during a read-only sync phase, as I expected. So yeah, I figured. All right, let's do something really dumb. This is not a good solution, but I just want to see if it works. This is still, oh yeah, okay, 1 picosecond. All right, now I think this is probably making sense. Didn't I change my time scale to be, well, whatever. I guess Icarus is just ignoring that, but okay, let's. So on this cycle, we send 1. On this cycle, we send nothing. On this cycle, we send 0, 1, 0, nothing, 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 nothing. Still nothing. On this cycle, we send 1. I mean, that does work. But it's not a good solution. VHPI, VPI. This is what I want. What the heck is this? Oh wait, callback data. Oh no, that's the user data. What the heck is this ARM callback? So who sets this callback data? Where's this M next phase? arm callback again. M read write. What the heck is that? Oh. I think I'm starting to get it. Too far. Okay, I think. Yeah. What is this? CD next sim time, finally. Gosh. Okay, so CB next sim time. Before execution of events in the next event queue. For reason next sim time, the time field is ignored. So oh, wait a minute. Wait, I think I have another idea. Because you can have your own custom triggers. Python triggers. No, that still won't work because this is not something I can fix just by reordering things in Python. Well, you know what? Maybe waiting 1 picosecond really is the best solution. Because it's a matter of taste, but I like when my waveforms look like this. Where the way that you read it is you look at the rising edge, you look at what's on the left to see what happened, and the signals for the next cycle are driven on the right. Now, I guess I can live with it if we don't drive them until like halfway through the cycle. I guess I'm okay with that. Well, if I'm okay with that, then why don't I just do that? So here on this cycle, we wrote 1. On this cycle, we wrote nothing. On this cycle, we wrote nothing. On this cycle, we wrote 0. On this cycle, we wrote 1. 0, didn't write. We wrote 0. Yeah, I think this is okay. What I'm confused about is how this is being driven at the right after the rising edge. That's a little odd. Oh, huh, cool. So yeah, valid would only be driven halfway through. And last would only be driven halfway through, which actually doesn't have to be the case. We can put this here. And now here, we can put this annoying, awkward behavior only when this weird flag is turned on. So let's do that. Okay. Okay, I think this is good enough. Ooh, wait, something changed. Maybe it's not. On this cycle, we sent 1. Nothing, nothing, nothing. Sent 0. Nothing. Sent 1. Nothing, nothing. Sent 0. Nothing, nothing, Nothing. Send one. Yeah, this looks good. Okay. 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 Uh, smooth streaming. Well, whatever. Okay. We're making progress. The next thing to do is man, we have two immediate problems. One is that there's no obvious way for me to drive both IA and IB, which is really frustrating. I mean, I guess if I allow the data to be a tuple and for the payload to be an array of tuples, that would work. Yeah, I think that's the best solution. Yeah, let's just go ahead and do that. Can you do that in Python, the length of the tuple? Nice. Yeah. Oh, actually, this should be here. Actually, I wonder if you can check if something is a sequence type in a better way. Check if something is a sequence. There's no nice way. Okay. Actually. All right. Line 51. Okay. That changed things. But I guess maybe random is actually random. Like it's seeded in a way I don't expect. So on this cycle, we send 1, nothing, 0, 1, 0, nothing, 1, nothing, 0. Yeah, this looks good. Okay, so now finally, so that solves one of our problems. B. Now here. We're getting there. We need to set last. Well, I guess we don't need to set last back to 0. We don't need to set the data back either because the valid goes back to 0. So now if I grab oh. Oh yeah. Okay. Okay, so this doesn't look immediately wrong. Now what I want to do is actually, do a test. All of this has a point, by the way. At first it was just to get up to speed with Coco TV, which I think I have enough familiarity with it now to move on and do interesting things. So the point here, though, is that I do know that I eventually am going to need to stream in floating point numbers and check if the calculation is correct, right? So I'm just starting on something simpler, just a simple integer addition. So how are we going to do this? I need to have, I now need to write a handshake receiver. Yeah, now I need to write a handshake receiver. Well, let's do that, because we need it eventually anyway. Actually, that's a better description of this one up here anyway. So there's no payload. And if data is provided, then the values will be pushed. The value will be returned. If multiple data list. If valid is provided. Also, this is hard to read. We're just doing some housekeeping. It will be used to determine when to stop reading datums and return. And return. If ready is provided, this function will drive it to 1 for as long as it is listening for data to do allow and suppression codes. If valid is provided, the sample to determine when data be read. If not, we'll assume that data is always valid. This function will return a list of none objects to indicate how many flips were received. Okay. There is a point to making this super fancy. I mean, I think I've said that multiple times now. Oh, whatever, let's just leave that out for now. We can add it later. Oh, man. I've been here for a while. I am starting to lose steam. Well. Let's see if we can at least do this. Oh yeah, I do need to. If not provided, then this function only reads a single flip. Tip: if you want to read the last bit, but only read flips one at a time, then simply add the last signal into the data tuple. Now I need to explain data. You can provide a list or tuple of signals, and each element of the returned data will be a list tuple of the same size as one entry for each signal. Okay. So this is where we're gonna do some ugly Python stuff. Ugh. Okay. Actually, question. Can you do... Oh yeah, stupid Python. And what happens if I do t equals thing, then t is still a tuple. Now what happens if I do t equals star thing? Okay. I guess we could just do thing 0, couldn't we? Yeah, okay. If ready is not none, then ready dot value is equal to 1. How did I do this up here? I'm really losing steam here. Yeah, okay, well, let's just do a while loop here. So that goes 0 while true. Okay, so is valid is equal to valid is none, or valid dot, I guess we can do this all in one line. Value dot integer equals 1. Is last is the same thing. And also we will do await read only. And then here await rising edge clock. If is valid, then if data is none, then we will do so ret will be an empty list, and we will do ret.append none. Does this work? Okay, good. Elif type data is not tuple, and type data is not list. Oh, you know what? Data is tuple. Then, ooh, how do you make a tuple of, I think you just need the tuple constructor, right? Yeah, okay. Equals tuple. Then we will do again, I'm making this function super fancy because I intend to use it in the future for other projects and maybe even at work. So there is value in doing all this. Okay, so if type of data is a tuple, then we need to read all of the wires. So for sig in data vals.append sig.value. And then here we will do ret.append tuple of vals. Very similar for it's a list, but we just don't need to convert to a tuple. And then finally, we just do ret.append data.value, like that. Now we do may as well no, let's just leave it where it is. Well, no, you know, if we have to wait for the rising edge, then we may as well wait for the rising edge. So here we'll do if is last, then break. Otherwise, we do cycles plus equals 1. Oh, and then here, if valid, we will do cycles equals 0. Now, while timeout equals 0, or cycles is let's leave that like this. And here we will do assert cycles is less than timeout. Timed out waiting to receive a flip. I think that's it. Okay, so, ooh, what did I screw up? Wait, what did I screw up? Oh, I didn't screw anything up. Okay, I don't know why, just the code folding got messed up. Okay, so now here, instead of a random driver, oh, but this has to return a value? Okay. But how do you know when it's finished? Oh man, oh man, oh man, oh man, oh man. Triggers triggers. We could fall get a trigger which fires. Okay. So HS receive. Okay, so now we're gonna do this. since we have support for it. .o overflow. .o valid. .I ready. .o last. And there is a clock you can use that I saw somewhere. Okay. Okay, so we did that. Now we will do await ev.wait. Is that how that works? I guess you just need to await it. And let's just do a little print message here. Waiting to receive packet. And just for my sanity here, let's also do okay, so we did that. Now instead of this random driver, I am going to wait for this tricky closure, but I think that's all I need actually. And then here, I am just going to, for I don't know, thing in queue, print thing. And the last thing I need is await yeah. All right, let's just see what happens. Simulation timeout, huh? Okay. So the clock is never toggling, which is a problem. So clearly this doesn't work. So why is the clock Z? How come their reset is Z? Man, what's going on here? Okay. Did I screw up how this timeout thread is supposed to work? But I did start soon, didn't I? Okay, well, let's just comment this out and see what happens, because clearly there's something wrong with that. TV has no attribute clock. What the hell is that? Man, friggin' Python is so... frustrating sometimes. None type is not iterable. Where? Line 246 for thing in queue. Well, doesn't this closure... okay, I need to know. This is going to be... Well, it'll be easier to do this on file. Oh. Well, okay. So that clearly doesn't work. Python closure. All right, what do we got? Non-local, what is this? How did this guy get zesty.ca? maybe this happens to you guys, but sometimes you find somebody's website and you're like, man. Anyway. I see. Well, now I know. All right. Q is still... Oh, wait, did I never return it? Oh, duh. Hey, okay, something happened. Is that right? I just put in random numbers here. So, hold on, let me just do this in a comment or something. So we have, this one here is 0, 1, 1, 0, 1, 1, 0, 0, 0, and we're adding to it the next one, which is 1, 0, 0, 1, 1, 1, 1, 0, 1. So if I add these two together, what I should get is 1, 0, 1, 0, 1, 0, 0, 0, 0, 1. Right? Yeah. And what did I get? Not that. Well, that's why we have a waveform. Also, we still haven't fixed this problem. What happens if I take away start soon? I mean, I can't see why that would make it better. Okay. Well, whatever. Let's just look at this waveform. So, oh geez, we got one of these. Right, I remember seeing this over here in the clock. Okay, so on this cycle, valid is 1, ready is 1, A is 1, B is 0, and the output sum is X. Oh, because carry is X. I see. Alright, let's just do this. It's a little cheesy, but a better way would be to have like a global event or something that we could wait on in arbitrary coroutines. But okay, we have some X prop, but it's a different result. Oh man, it's a worse result. Oh, duh. Well, it's less wrong, but it's still wrong. Okay, so that fixes that. On this cycle, one plus 0 is one. So that's correct. Wait, hold on, what's going on here? Oh, my bit strings are backwards. I see. That's why. So this is actually 0, 0, 0, 1, 1, 0, 1, 1, 0, and this is 1, 0, 1, 1, 1, 1, 0, 0, 1. So this is actually 1, 1, 1, 1, 0, 1, 0, 1, 1 with a carry of 0. Is that what we got? We get the LSB first, so it's 1, 1, 1, 1, 0, 1, 0, 1, 1 with a carry or an overflow of 0. Okay, this is actually right. All right, let's go ahead and push this to Git. Also, we don't need this anymore. In the extremely unlikely event that somebody is watching this as an example of what it looks like to develop RTL and doesn't already know what it's like to develop RTL, I hasten to point out that it took me like probably 10 minutes to write this. Yeah, 10 minutes to write this, and something like 5 hours or 4.5 hours to do the rest of it, right? This is typical. Writing RTL really is like, I mean, I wouldn't say it's trivially easy, but compared to verification and all the hassle involved in verification, it's tiny. Okay. Although, to be fair, a lot of the stuff I did in here was making like super fancy reusable functions that I won't have to rewrite again. And there are some problems that I solved that I won't need to solve again, so maybe it's not quite a fair, you know, comparison. I don't know why the code folding is so messed up here today, but whatever. Okay. What next? The next thing I need to do is be able to do random testing where I send in random values, read them out, and confirm that they're correct. So how do we do that? I think the idea is we'll have a queue of inputs and a queue of outputs. Every time we push an input into the simulator, we will calculate what output it's supposed to have, and then push that into the queue of outputs, and then we'll start a monitor thread. And every time it reads an output, it'll compare it against the one at the head of the queue. Well, we can do that when the time comes. What I'm really interested in doing is actually doing a streaming multiplication, which is not as easy by any means. I mean, this is what I wanted to do when I sat down this morning at 7 a.m. What time is it now? 12:15. I'm finally getting to it. Only now I'm starting to, now that I'm actually thinking about it, I'm realizing what I'm trying to do here may not be possible in the way that I was hoping. Because I don't know if we can do it in O of 1 memory, whereby O of 1, I once again mean that you can change at runtime how many bits to stream through. So, okay, now it's time to make a drawing. Okay. So let's just work with some two test inputs. So A zoom in a little as well so it's not so small. let's say it's 1, 0, 0, 1, and B will be 0, 1, 1, 0. Now, let's just go ahead and do the multiplication out by hand the dumb way. I think this is called the, what do they call it, the school child's algorithm or something? I think schoolroom method or whatever. So we have 1, 0, 0, 1, 0, 1, 1, 0. Let me just align this to the right. So, whoops. So, 1, 0, 0, 1. 0, 0, 1. Oops. This is actually not a great example because there's no carries, but well, let's just do that. Is that correct? One, 1, 0, 0 carry the 1, 0 carry the 1, 1, 1, 0. So this should be 99 in binary. Let me just check that. Yeah, okay, that is correct. I did it right. I haven't forgotten how to multiply numbers. Now, how could we do this by streaming it in 1 bit at a time? Well, the obvious thing to notice here is that there are 4 bits of each input and 8 bits of output. So clearly we can't stream it in 1 bit at a time. And also the thing to notice here is that well, what if I tried to draw the dependency? The data dependencies. Okay, this is getting hard to draw. I don't see a good way to draw it, so I'm gonna have to do something stupider. just going to label them all and draw them in a hash diagram. And here I'll just use lowercase letters for these. Why not? Okay, so this is going to get messy, but so A depends on everything, but it immediately depends on, oh, and there's all these carry bits. So here's what I'm trying to do in my head here, and it's hard to vocalize it. So here you may think, okay, so first let me start by labeling all the carried bits. So maybe I'll put that in here. So let's call these carry bits. We're going to need 6 of them, so HIJKLM. Also, let me label these as carries. KLM N. And actually, let me write them in. So this carry is 0. This carry is 0. This carry is 1. This carry is... Man, this is hard to read. That carry is 1. This carry is 1. Wait, 1, 1, 0. 0 is a carry of 1. 0 is a carry of 1. 1 with a carry of 0. And then 1 with a carry of 0. Okay, now here's what I'm trying to do in my head here. If we take a look at this bit L in the carries, it is dependent on the sum of I, N, S, and Z, right? What I'm trying to do in my head is create intermediate nodes in the tree of dependencies such that the tree is a binary tree. So here, instead of drawing that L depends on I, N, what did I just do? I, N, S, and Z. Instead, what I would do is I would do something like this, where I would create 2 new quantities. Let's call them, I don't know, friggin', what letters do I have left? I have O, P, I don't immediately know why I'm doing this. It's just I have an intuition that if I can make this into a binary tree, it'll be clearer to me how to design the hardware for it. By the way, I'm sure this is a solved problem. I'm sure this has been done before. I by no means think I'm breaking new ground here. But it's the kind of thing I want to try myself. I mean, this was the point of the project, was to think about how to do stuff like this. So yeah, let's just go ahead and draw the graph. This is going to be a little tedious. Yeah, this is going to be really tedious, but let's only go as far as L. How about that? And actually, I wish I had deleted those, because if I'm only going as far as L. Okay, so I, what is I? I is from, how did I do this? Is from H and A. And N is from G and B. I'm gonna have some duplicates here to deal with, but like don't worry, like I'm gonna deal with it, but I need to draw it first and see it once before I can clean it up. S is from F and C. And Z is from E and D. Okay. Fascinating. Actually, this is it, right? This is the whole graph for L. Oh, but L also depends on M. Yeah. Yeah, okay. I knew something was missing. And now M depends on J, O, and T. So let's do it like this. Actually, let me do it like this. Now, J depends on H and B. So for now, I'm just going to write the letter a second time, and then later I'll organize this better. O is going to depend on G and C. T is going to depend on F and D. And of course, M depends on N. We're almost done. And now N depends on K and P. And what does K depend on? K depends on H and C. Now, there is an algorithm to go from a diagram like this to a Hass diagram, which I'm just kind of going to do intuitively. I'm not really going to run any code or anything like that. But this is something I'll point out, is that if I knew how to use like the usual like graph tools, this would go a lot faster and be less tedious. Anyway, so K depends on H and C, and then P depends on G and D. And then finally, that's it. Right? Because N depends only on K and P. All right, now what we need to do is basically what we're going to do is the root of our Hass diagram, or root of our tree, or whatever, is going to be L. And what I'm going to do is, for each of these quantities, I'm going to measure its maximum distance from L. So H, C, G, and D are 1, 2, 3, 4 away from L. Also, I just realized this isn't a binary tree. Shoot. Well, let's leave it like this and see what happens. So L and then O, P, and M are all one link away. Let me change the color here. OP and M are all one link away. Then what are the links that are 2 away? We've got I, N, S, Z, J, Q, and N. So where this is ultimately going is once I have this diagram, I'm going to schedule certain operations into certain cycles, such that at any given moment, we're only working with a few operands at a time. That's the idea, or at least that's the intuition. And whether it works or not, it'll be a different story. Okay, now what are all the things that are 4 links away? Now here, I know that all of these appear later on. So the things that are 4 links away are O, T, K, and P. And then finally we have all these guys, which I don't really quite know how to write them in an order that will be useful, so I'll just copy them from here and go for it. Yeah, this is going to be kind of ugly, but hopefully it will make things clear to us how to do this. All right, let's use the straight line tool because otherwise we're going to lose our minds. Oh man, this is getting terrible. Strange that E only appears... Oh no, it's not strange that E only appears once, because, yeah. Okay, so to create a streaming circuit, to do this, we need to follow a few rules. Rule number 1. Oh, but I think we're already screwed because, you see, we only want to read each input once, because otherwise we would have to, if we had to Well, I guess we could read the same input on two adjacent cycles. So I guess we can change this to once, oh, here I need this. Once input changes, it will never go back to a previous value. Two. So at any given moment, we can see the inputs for this cycle and some finite number of memory bits. 3. It has to work. In other words, all right, let me be more precise. When computing output and next saved state, must only rely on current input and saved state, which is obvious, but you know, I'm just writing it out here for the sake of writing it out. So what does that mean from a graph theory point of view? Oh, no, these didn't connect. Well, that's too bad. What does that mean from a graph theory point of view? So, goal, draw bubbles circling values used at, or draw one bubble for each clock cycle. It must contain no more than, we can see, and some finite number n of memory bits. Oh no, and I have a name collision, don't I? X. No more than x intermediate values. I guess I don't need this stuff on the left, so I can make this text box a little wider. Our goal is draw one bubble for each clock cycle. It must contain no more than x intermediate values and can only have edges going to one other bubble representing the previous clock cycle. Also, this looks weird. Right? So is this possible? So let's just try something. Let's say that on the first clock cycle, let's give ourselves 4 memory bits. Why not? Just because I happen to have 4 right here. Well, already we're breaking a rule. Okay, so there's another rule. There's another constraint. By the way, each bubble can only see up to y inputs depending on how many inputs we stream in per cycle. In this particular case, this is a multiplier with 2 inputs, so set y equals 2. Right, so this bubble see this each bubble must contain any inputs that are needed to calculate its intermediate, to calculate the intermediate values saved inside of it. So let's just start it with O. Let's say this is our first cycle. Then O must contain C and must contain G. Now, you know what, that's kind of a awkward shape. Let me just do it like this. That's also weird. Now, let's say let's contain all inputs okay. For each bubble, we also need to mark what it depends on. So now let's say we do T next. Well, we better not do T next. Maybe we should do P next. Let's say we do P next. The reason is because they share G. This is impossible to see. Oh, and actually, because we're gonna hang on to O, this bubble actually needs to contain O. I'm not seeing it. I am not seeing it. This may not be possible, what I'm trying to do. We're not done using G yet. We still need it for N. We're not done using D yet. We still need it for Z. And by the way, let's not forget that although I didn't draw it, all of these inputs are used again for all these intermediates. Yeah, because like, if we have an m by n multiplier, then we have m times n intermediates. And the dependency is like in a matrix, like in this particular 4x4 multiplication, every input bit is needed for 4 output bits. And as another example, sorry to colorblind viewers, right? And yeah, this is just not possible. I don't think this is possible because, okay, let's start with this simpler constraint, which is, let's say that every input will appear for 1 clock cycle. Well, no, you know what? All right, let's do a simple constraint, but one that is still concrete. We know that if the inputs have the same size, which we'll enforce for now, that the output will be twice as long, have twice as many bits. So let's say that each input appears for 2 cycles. Then that means that on each cycle that an input appears, we have to calculate all of the intermediates that depend on it. But the problem is, so let's say we picked D. We want to calculate all of its intermediates. We have 2 cycles to do it. Well, let's say we do it in 1 cycle. We just do all of these. Well, first of all, this doesn't, it still doesn't work because the number of intermediates that depend on D is linear, in fact equal, to the size of the other word. So even if we give ourselves 2 cycles, because, you know, we need twice as many output bits, even if we give ourselves 2 cycles to see the input, we would have to do n over 2 intermediates and save them for whatever it, well, okay, I thought of something else here. What if we relax the constraint that we can only see 1 bit of the input at a time? Just, I mean, okay, so let's suppose that I can see all of the first input for every single cycle, and I'm streaming the second input in one bit at a time. Well then, well no, because then the amount of memory is still linear in the size of the first input. Okay. What if we hang on to the first input for as many bits as there are in the second input, stream that many outputs, but they won't be complete outputs, then we have to stream those outputs back in when we move to the next bit as the input. So let me write out exactly what I mean by that. So let me just paste this. So first what we do is we grab bit D, which is 1, and then we stream in over multiple cycles. So let me maybe do this. No, wait. So let's do in A, in B, and so in A will be 1, in B will be, and then out. Right, so these are all D. We repeat D for 4 cycles. Well, actually, it would be better if I did it like this. So then this would be, and so this is going to be an intermediate value that we have to cycle through again. So actually there isn't in C, which is all zeros right now. This is just initial condition. So I won't label it. And so what we get is 1, 0, 1, 1. And let me label this with lowercase letters, not to be confused with the lowercase letters over here. I just need a different set of letters. Okay, so then what we do is now we feed in C. And then we cycle through E, F, G, H again. And we also need to feed in the A, B, C, D, except I think we just need A, B, and C. Let me just try that. So this is still going to be 0. And 1, 0, 1. So then let's So what we get here is, oh, I did this backwards. Okay, this is worth changing before I go any further. This is a little weird, but I think you get the idea. So all I'm doing is I'm just adding down the column and carrying into the next one. Oh, what do we do with the carry here? Oh, you know what? The carry from this column goes here. So let me call this, I don't know, $sign or something, or whatever, to indicate the carry. So here I add down the column. Oh, no, I don't add down the column. I multiply these two and I add it to this. So what am I doing here? So actually here I multiply 0 by that and just add that. So I get 0, 1, 0, 1 with no carry. Okay. Now, by the way, the first So let me just, I'll explain what I mean by these red circles in a second. Or will I? Wait, do I even know what I mean by those red circles? So also let me just do out the multiplication here and the way that I'm doing it above to make things easier on me. And actually, let me go ahead and do this. Yeah. So this guy is this guy. This guy I get it. Oh wait, do I get it? Yeah, I did it wrong. I see. So CVA goes here, and the carry goes here. Oh, but now I need to store CV and A. I need to store. Well, okay, let's just keep going with this. Okay, then this one. Is that one. Now this is E, and then whatever the carry was on that, which I need to save. So G is 0, F is 1, E is 0, the carry was 0. G, H, I, J, K, L. Okay, so now here's the rule. We multiply in A and in B, which is done using an and then we add it to whatever's down here. So here we have 0. We just copy it because it's 0. And then this guy is that guy. And then finally, right, so we've shifted out 1, 1, 0. Yeah. So 1 times 1 is 1, plus 1 is 0, carry the 1. So 0, carry the 1. 1 times 0 is 0, plus 0 is 0, plus 1 from the carry. and then no carry. 1 times 1 is 1 plus 0 equals 1, and then no carry. And then finally, we have that this, well, this is that, this is that, and so on. So let me do it like this. Oops. Whatever, doesn't matter. You get the idea. Now, the reason why this might be okay is because wherever we're getting these inputs from has to save all the inputs. Or does it? Because in principle, if the whole thing was streaming, then these inputs might only be available 1 bit at a time. I mean, our output is only available 1 bit at a time. And also notice here that we need to save 4 outputs. Yeah, this just doesn't work. I think what I'm trying to do is just not possible. Let me just leave a note for my future self here. Percent is carry, or percent, the pound symbol is carry. Carry out. Whatever. I'll know what that, I hope I know what that means next time I look at this. Yeah, I mean, yeah, I think this is just not possible. Well, I give up. I have no more ideas. I have accomplished what I wanted to accomplish anyway. Well, not really. I mean, I guess I did figure out a way to get Coco TV working inside of Replit here, and even with the waves, and I do have some functions I can reuse for future projects. But my original idea of what I wanted to do is, at least in the way that I have set out the requirements, I'm pretty sure, like 99% sure it's not possible. So I'll have to think of a different project. Well, okay.